Okay, so let's go through problem 3 from the week 4 discussion lab. The compass of an airplane flying in a crosswind indicates that it is headed due north, and its airspeed indicator shows that it is moving through the air at 240 kilometers per hour. If there is a 100 kilometer per hour wind from west to east, what is the velocity of the airplane relative to the Earth? Okay, so this is a question that tests our concepts of, first, relative velocity, second, the concept of frame of reference, and once we get those all put together, it'll test our understanding of vectors. Okay, so relative velocity and frame of reference are related here. When you're measuring velocity, it matters what you're measuring the velocity with respect to. All right, so in the first part of this problem, they describe an airplane flying and its velocity is measured relative to the wind, right? So as far as the airplane is concerned, it is flying due north, it is oriented due north, and its airspeed indicator, so the velocity of the airplane with respect to the wind, is 240 kilometers per hour. Okay, but the wind may be moving, so that means we have a frame of reference, a coordinate system, which is possibly moving with respect to the Earth. Okay, and so here in the second part of this problem, they indicate that the wind is moving at 100 kilometers per hour from west to east relative to the Earth. All right, so the wind is moving relative to the Earth, the airplane is moving relative to the wind, and we want to know what is the velocity of the airplane relative to the Earth. All right, so we have different frames of reference and different objects, and we have to somehow straighten this all out. All right, so the first thing they talked about here was the airplane. As far as the airplane is concerned, it is oriented due north, right? It is flying, its compass is saying it's flying due north. And it is moving relative to the air at 240 kilometers per hour. So let's draw that as a vector. I'll draw a vector pointing due north, and I'll label this the velocity of the plane relative to the air. All right, so that's the notation we typically use for these type of problems, where the first letter indicates the object we're talking about, the plane, and the second letter talks about the frame of reference, the air. All right, so this is equal to 240 kilometers per hour. Okay, but then we also know that there is a wind. The wind is moving at 100 kilometers per hour from west to east. All right, so there is a wind, and I can draw that as a vector, 100 kilometers per hour from west to east. Okay, and so as this airplane is moving, it thinks it's moving due north, but it is also getting pushed to the east by this wind. So the actual path taken by the airplane is this one. Okay, because it's getting pushed by the wind as it flies. So I can label all of these. This is the velocity of the plane relative to the ground, and this is the velocity of the air relative to the ground. Right, so just by drawing this picture, we can now just write down an equation that describes this, because I can tell that the blue vector plus the orange vector better give me that green vector, just by using the tail to head method for adding vectors. All right, so putting this all together, I can write down that the velocity of the plane relative to the air plus the velocity of the air relative to the ground is equal to the velocity of the plane relative to the ground. All right, just using the tail to head method, I can write down that equation. But all I really need to solve this problem is really the picture, because we want to know this green vector, right? We want to know the velocity of the plane relative to the Earth, or I guess I labeled it the ground. So we have a triangle here. We can use trigonometry. I can find this angle theta, and I can find the magnitude of this green vector, and that's all they really want to know here. All right. They told us the velocity of the air relative to the ground is 100 kilometers per hour. And so I know both sides of this right triangle. I can figure out the hypotenuse, which is that green vector, using our definition of the Pythagorean theorem. So the velocity of the plane relative to the ground is going to be given by the square root of the velocity of the plane relative to the air squared plus the velocity of the air relative to the ground squared. All right, and I can write down this equation just because I have this triangle and I can see it's a right triangle. Right, the blue vector is north-south, the orange vector is east-west, so they're definitely perpendicular to each other. And so plugging into this, I have the square root of 240 kilometers per hour squared plus 100 kilometers per hour squared. And when I run that through my calculator, I get 260 kilometers per hour. Okay, just keeping the units as they gave it to me in the problem. And what is this angle? Well, I have the opposite of this angle is the velocity of the air relative to the ground. All right. The adjacent to this angle is the velocity of the plane relative to the air. So I can find the angle as the tan inverse of opposite, which was at 100 kilometers per hour, divided by the adjacent, which is 240 kilometers per hour. And so solving that, I find that the angle is 22.6 degrees, and that's 22.6 degrees east of north. Right? We're measuring with respect to the north. Okay, so we can describe this vector, this green vector, using these two numbers, 260 kilometers per hour, 22.6 degrees east of north. Or we could write down the components of this vector. Right, the components of this vector are actually really easy to write. Right, it's 100 kilometers per hour I hat plus 240 kilometers per hour j hat. Right, so the components of this vector are just the sides of this triangle. Okay, so let me know if you have any questions on that problem.